Okay, so hi everyone, my name's Alex, and this is my sixth basic chemistry tutorial, and for this one I'm going to be explaining polymers. Now, let's get started. So, polymers. What are polymers? So, polymers are very long chains of molecules which occur where lots of small molecules join together, and the small molecules are called monomers. So, a lot of monomers join together to create one polymer, whereas the overall big molecule is called a polymer. The monomers are joined together by covalent bonds, which is the sharing of electrons. Now, the majority of polymers are made from hydrocarbons, and then they have other elements added to them, such as chlorine or fluoride, but the majority of them are just basic hydrocarbons, and these are formed by the sharing of electrons. An example of a polymer includes polyethylene, which is a waxy solid and has a very low density, and the products that polyethylene is able to create includes plastic bags, bottles, and plastic boxes. Now, what I find interesting is I used to watch a program called Breaking Bad. It's a really good program, and there's one instance where Walt, the main character, is a chemist, and he asks Jesse to buy a specific container made of a specific polymer, just so that the acid won't seep through the container. Now, I've read up this. I think some of the science at Breaking Bad is a bit dubious, but the acid that was used to burn the body, that the plastic needs to contain, because it won't go through the plastic because of the way the polymer is built, is called hydrofluoric acid, which is hydrogen fluoride in water, and it's a really corrosive acid, so it has really extremely high reactivity towards glass and other metals, and it's stored in plastic containers. Now, I'm sure from the program that the container that Walt wants is chlorosulfonated polyethylene, which is a polymer product of chlorine and sulfur dioxide. The polymer is also a rubber and is superior to others due to its resistance and due to its resistance to acids like sulfuric and nitric acids. So what I'm saying is that polymers can be used. Majority of them are like plastics or rubbers or anything like that. They're used to contain acids because the bonds between the molecules, they're that strong that acid can't get through them. And one example of this is chlorosulfonated polyethylene. I just thought I'd show that reaction and show that example. It's a really good example, really, to be honest, because it's relatable, and plus, basically, they tried to put the hydrofluoric acid in the bathtub, and that obviously didn't work because the hydrofluoric acid melts through ceramics, which is what the bath is made of. But if the acid was put in the chlorosulfonated polyethylene container, then it wouldn't have gone through the container because the chlorosulfonated polyethylene is built because of the arrangements of the monomers and polymers within the polyethylene, that it can withstand the acid so it doesn't burn through. So hopefully that's given a bit more insight into polymers. There we go. Oops. That's what happened when it burned through the bath and it saw the body. So more on polymers. So the differing polymers will also have different properties. So polythene is used in plastic bags, whereas polypropylene is used in crates. A polymer's properties are dependent on the chemicals that they are made from. See, as I said earlier, I think all polymers are initially made from hydrocarbons, but obviously they come into contact with other elements such as chlorine, hydrogen, anything like that. An example is there's low density polythene and high density polythene, where low density isn't as strong as high density polythene. The polymers are also very unreactive, so they can be used to store chemicals without blowing up. They store chemicals and food, and that's extremely important because you don't want food getting contaminated really quickly. And since some polymers are used to recycle things, they recycle themselves back into plastic bags, but a lot of them take a lot of time to be recycled, and it's the same topic with carbon fibre. It's a really good product to use and to have, but it's extremely difficult to recycle, so you're just stuck with a product at a landfill site just taking up space. And the last thing, chemical structure. Since I said earlier, most polymers are formed from hydrocarbon molecules, which lead to single, double, and even triple carbon bonds. The chemical formula for polyethylene is C2H4, meaning that there's 2 carbon atoms and 4 hydrogen atoms, which make up polyethylene. Now, obviously, there's like a single bond there, single bond there, single bond there. Now, that's just one. We put things like polypropane, or all the other longer ones, like polypropylethylene, or something like that. There'll be more bonds and there'll be more atoms inside them. But that's just the basics of polyethylene. So we'll go over it one more time. So polymers are very long chains of molecules which occur when lots of small molecules join together, and the small molecules are called monomers, whereas the overall big molecule is called the polymer. The monomers inside the polymer are joined together by covalent bonds, which is the process of sharing electrons, not trading electrons, sharing electrons between the atoms. An example of polymers include polyethylene, which is a waxy solid and can be made to create plastic bags and bottles. So the Breaking Bad, so the hydrofluoric acid, so the chlorosulfonated polyethylene, which is a polymer product, can withstand the high corrosiveness of the hydrofluoric acid because of the arrangement of the monomers and polymers within the chlorosulfonated polyethylene. And there we go again. So the different polymers will have different properties. So polyethylene is used in plastic bags, polypropylene is used in crates. The polymers are also very unreactive, so they can be used to store chemicals without blowing up. And then the last thing again, so most polymers are formed from hydrocarbons, which leads to single, double, and even triple carbon bonds. The chemical formula for polyethylene is C2H4 because there's 2 carbon atoms and 4 hydrogen atoms. So yeah, that's the basis for polymers. There is a lot, you can go a lot more into it. This is just basics, you know, just what it is, what it does, examples, a real life or fictional example, but could be real life if you're in that situation. I hope you're not though. I hope you're not trying to think how to store a dead body, because that's what they did in the story. They had to burn the dead body, but that failed. And yeah, just properties of polymers. They have different properties: low density, they're unreactive, and their chemical structure. So yeah, thanks for watching. Hopefully you've learned something. Sorry if I went a bit too quick or stuttering, but I get a bit nervous when I do commentaries or videos. But yeah, thanks for watching. See ya. Bye.